Hey everyone, in this lecture we are going to talk about searching and sorting. So let's start with searching. Basically we are going to search for an element in the array or a list and then return the location or the position or the index of that element if it is found. If it's not found, then we're going to return -1. We're going to explore two algorithms for that purpose. The linear search, sometimes called sequential, or the binary search. Right, so the first search. So as I said, it's called also sequential, and it consists of starting at the first element, one at a time, starting from index 0, sequentially stepping through the array, examining each element until either I'm going to find what I'm looking for, or I'm going to get to the end of the list, and then I will conclude that the element is not found. So let's have an example. So here we have an example, an array. As you can see, the list is not sorted. It doesn't have to be. And let's say, for example, we are looking for number or value 11. So we're going to start from the beginning. We're going to compare 11 to 17, to 23, to 5, and 11. So it will take us 4 comparisons before we can find 11. Now, what about if the value or the number or the elements we are looking for is not there? We still have to search the entire list. So I'm going to compare 7 to 17, to 23, to 5, 11, 2, 29, 3. So basically, it will take us the size of the array, which is in this case 2, 4, 6, 7 comparison before we can conclude that the number 7 is not found. So let's look at the code for linear search. Now, as you can see, this is the linear search function. It takes 3 parameters. So we have the array, the list, the size of the array, how many elements we have, and the searching number or the target. Now we need 2 variables. One variable called found of type Boolean. So we're going to assign it to false because we're going to assume that it's not found. And we need a variable of type integer k that's going to keep track of the index. So we have the loop while k is less than size because we're going to start from 0, 1, 2. As long as k, we did not get to the end of the list and found it's false, we did not find what we are looking for, keep searching. If we find it, as you can see, if it matches, then found equals true. Else, if it's not found, then move on to the next one. And then you keep doing this over and over, okay? As you can see, we have 2 conditions, and either we're going to get to the end of the list or it will be found. So if we found it, then return the location k, otherwise return -1, which means it's not found. Now, what are the benefits or advantages and disadvantages of this algorithm, linear search? So the main benefit is that it is an easy algorithm to understand and to implement. Okay, and then another benefit is it does not really matter what kind of array or list. It does not have to be in order. It could be any order. Disadvantage, the main disadvantage is that it is inefficient, especially when you have more elements, then it will take us more time. Like, for example, the worst scenario is that the element we are looking for is toward the end, or it's not found. We will end up searching every single element in the entire list. So that's definitely not the most efficient. Another algorithm is called binary search. So what is binary search? Before we talk about the binary, before we use it, it's very important to remember that there is a requirement, there is a condition that you have to make sure it's there before you use binary search. The list has to be sorted. If the array is not sorted, then we cannot use binary search. It will give us basically misleading answers. So binary search basically consists of dividing the array into half and then focus on the middle number. middle number. If it matches our target, then we're going to return the location. Otherwise, we're going to focus only on one of the two halves, because since the list is sorted, then if our target is bigger than the middle number, then we just have to focus on the right side of the array and then ignore the left side. If our target is less than the middle number, then we're going to ignore the right side and focus on the left side. Let me give an example just to make sure you get the point here. So let's say we have an array. As you can see, it is sorted. We have 14 elements here. So let's say, for example, that we are looking for number 60. All right. So we need three variables. We need a variable to keep track of the lowest index and the highest or the largest index and the middle one. So as you can see right here, we're going to start by default. We'll start from 0, that's the smallest index, and the largest index is the last one, 13. So if I add them up, 0 plus 13 divided by 2, that's going to give me the middle number, which means the middle index is 6. Now I'm going to compare 60, that's the one I'm looking for, to 45. It's not the same, right? It doesn't match. So what I'm going to do, I'm going to ask the question, is 60, the number I'm looking for, is it bigger or less than 45? Definitely it's bigger. So I'm going to focus only on the right side. That means I'm going to focus on the right side of 45, like 40, 52, 60, 60, all the way to 93. Because there is no way for 60 to be on the left side. I'm just going to ignore that. So I'm going to change small. Small will change. It will be number 7. That means because 45 is the middle, so that's going to be the middle plus 1. So now small will be here. So now I'm going to focus on this small. It's like the array keeps shrinking. Every time we divide it by half, it keeps shrinking. Either I'm going to find what I'm looking for, or I'm going to run out of number. So now small is whatever the index of the middle number plus 1. Now I'm going to continue the process again. So what is the middle number here? 7, which is the index of the smallest, plus 13, so that's 20, divided by 2 is 10. So now the middle number is 75. Is 75 equals to 60? No. Is 60 higher or less? It is less. So I'm going to focus on the left side. Now I'm going to change large. Large will be whatever the middle, which is 10 minus 1 is 9, as you can see right here. Now I have only 3 numbers left. Again, 7 plus 9, 16 divided by 2 is 60. I found it. So it took me three comparisons to find my target 60. So that's how simple it is. As you can see, we found 60. Okay, took us 3. Now imagine we use linear search. We have to compare it to 15, 18, 23, 20. Basically 1, 2, 3, 4, 5, 6, 7, 8, 9 passes. For 9 comparison. For binary search, we just use 3. All right. Now let's switch to, I'm going to stop sharing here and then use another example. So I'm going to use, let's see if I can use the whiteboard for here and then use an example. Okay. All right. So let's use an example. I'm going to get a pen here. So we need a list that is sorted. So I'm going to use, let's say, for example, 2, 4, and then let's say 8, say 9, 12, 14. So I'm coming up with random numbers, but they have to be sorted. So 16, and then we have, let's say, 19, and then let's say 21. How many numbers do we have? 2, 4, 6, 8, 9. I'm going to add 2 more. And then let's say 30. And then let's say 34. Okay. And then I'm going to put the index because I need that. This is 0. This is 1. This is 2. This is 3. This is 4. This is 5. This is index 6, index 7, index 8, index 9, index 10. Okay. So how many variables do we need? We need 3. The lowest or the smallest index, and I need the highest index or the largest, and then the middle one. That's how the binary search works. When we start, what is the lowest index? Is 0. The highest index is 10. Okay? So I'm going to add them up. 0 plus 10 is 10 divided by 2 is 5. So this is the index of the middle number that I'm going to compare it to my target. Now before, what am I looking for? So let's say I'm looking for number 9, for example. I'm looking for number 9. All right, so I'm going to focus on 5. What is 5? Is this one right here. This is how the binary search works. It is focused on the middle number. So I'm going to compare 9 to 14. So 9 is less than 14. That means 9 has to be on the left side, which means I have to search the left of the array. So if I'm searching the left of the array, I'm not going to change the lowest, I'm going to change the highest. So 0 will be the same, and the highest would be whatever the middle, the index of the middle number minus 1. So that can be 4. So now my array will shrink, will be only from 0 to 4. And then I'm going to add them up. 0 plus 4 divided by 2 is 2. So which one is 2? It's right here. Remember that this side is gone because there's no way for 9 to be here. So now I'm focusing only on this 2. So what is 2 is 8. 9 is higher than 8 because that's where, 8 we have it at index 2. Now I'm going to search right. Why? I'm sorry, search right, yes, because 9 is on the right side of 8. And then when I'm searching right, I'm going to change the lowest. And the lowest will be whatever the middle plus 1. So it's going to be 3. And then here, it's not going to change. 3 plus 4, 7 divided by 2 is 3. Oh, now I found 9. So 9 is equal to 9. So we found it. So how many passes, how many comparisons did it take us? 1, 2, 3 only. Okay, so 3 passes. So this is how the binary search works. Now, what about if the number is not there? Let me see if I can go back here. Oh, let me start a new one. So I'm going to close this and then start a new one. So I'm going to start with 1. Then this time I'm going to see what about if the number is not there. So let's come up with the other numbers. So let's say we have 1, we have 3, we have 6, we have 7, we have 9, we have 12, we have 14, we have 16, we have 19, we have 21, so 2, 4, 6, 8, 10, 7, and 25. Just an example. Okay, so the first index is 0. What's the last index? 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now again, we need 3 variables. The lowest, the largest or the highest, and then the middle. Okay, so in the previous example, we are looking for something that exists. Now, what about if something that's not, it does not exist? So let's say something that's not there. Let's say number 20. I'm looking for 20. 20 is not there. But let's see how the binary search will find out that the number 20 is not there. So we start from 0. The last one or the highest one is 10. So you add them up, divide them by 2, that's 5. So that's the first number we're going to examine. So 0, 1, 2, 3, 4, 5, 12. That's the one in the middle. So what I'm going to do, I'm going to compare 20, which is our target, to 12. So I'm going to compare them. So of course, 20 is higher than 12. So I'm going to search right. There is no way for 20 to be on the left side. I can just ignore this part right here. So now if I search right, I'm going to change the lowest. It will be whatever the middle index plus 1, so it's going to be 6. The highest will not change. Right here. 6 plus 10 is 16, divided by 2 is 8. So which one is 8? This is 5, 6, 7, 8. So 20 is higher than 19, which means I have to search right, because 20 has to be on the right side. And then again, I'm going to change the lowest now. So the lowest will be whatever the index of the middle, 8 plus 1, 9. And this is 10. So you can see it keeps shrinking, like the lowest and the highest variable, they keep getting close to each other, which means we are getting less until we run out of numbers. I think they overlap. So 9 plus 10 what? Is 19. Divided by 2 is 9. Remember, there's no 0.5. So what is 9? So this is 5, 6, 7, 8. 9 is 21. So 20, pay attention here, is less than 21. So 21 is this number right here. So if 20 is less, that means I have to search left. And when I search left, which of the variable, low or high, it will change. Looking left, so the highest will change. So I'm going to subtract 1 from 9, which is 8. And then pay attention here. How does the program know that the number is not there? Because the lowest becomes bigger. That means we overlap and there are no more numbers left. As you can see right here, 0 is less or equal than 10. 6 is less. So all of them, lowest is always less or equal. Once lowest becomes bigger, then it's not found. So I'm going to put here, not found, because that's how the program find out. Is there is no, that means there's no more number left. So no found. Now we're going to look at the code and see. Okay, so let me close this, and then I will share the PowerPoint. Okay, right. So let's look at the code now for the binary search. Consider. So this is the binary search. Right. As you can see, the binary search function takes 3, just like the linear search: the array, the size, and the searching number. Now we talked about this. Now it should make sense to you. We have found false, because we are assuming that it's not there, and we need 3 variables: lowest, highest, which is size minus 1, and then the middle number. We can put 0 or don't put anything. Now, as long as the lowest is less or equal, and we did not find what we are looking for, then the middle, you add them up, you divide. That's exactly what we've been doing. Divide by 2. If it matches, then that's it. We are done. Found equals true. Otherwise, if it's not found, then we have 2 situations. Either our target searching number is higher, and in this case, we're going to search right side, and then in this case, the lowest will be mid plus 1, exactly what we did. Or the searching number is less, and then in this case, we have to search the left side, and we're going to change the highest by subtracting 1 from the middle. So you're going to keep doing this over and over until either you find what you are looking for, and in this case, you have to return the location, or you're going to conclude that return a negative one, that means it's not found. I hope you find that one useful. Thank you.